Okay, so we had done in the earlier video as looping algorithm. So after doing the slip and Dewey algorithm, let us actually understand the same actually network which we did for looping algorithm, how that actually can also be solved using the same pulse matrix technique. Okay. So I had this time I will again take same 4 by 4, I had taken it earlier also. Okay. So we have to set up the connections here, I can just define and now this time instead of using looping algorithm we will be actually using the same pulse matrix, and you will be able to appreciate that looping algorithm is nothing but the same thing which we actually were doing. We ensured that that chaining happens properly. So if you want to set up a connection say 1 to 2 prime, 2 to 3, 3 to 1 prime and 4 to 4 prime. Let us try it out if this is going to work out. So 1 2 3, let me take a colored chalk again. So when I want to set up 1 to 2, I can do it whatever way I like. I can do it this way and then this is connected. Okay, 2 to 3, maybe 3 to 1 I would like to set up. The only way is going by this way. In fact, there is not going to be any blocking in this case. Right. Or maybe I can introduce a blocking by setting up this, then 4 to 4 I will set it up. Now I want to set up 2 to 3 prime, I have no path. So I cannot go here, I cannot go here, it is not possible, the blocking has happened. So let us look at the pulse matrix correspondingly. So in this case the pulse matrix will consist of a 2 by 2 is a very simple one. We can try out then for 8 by 8 also and do the same exercise. So in this case 1 is connected to 1 by upper, so I am going to go this upper and lower. So 1 is connected to 2 via upper and the 4 is connected to 4 via lower. Now when I am trying to connect 2 to 3, what I am doing is I am actually trying to put an element here. Look at the row, look at the column, union of these two consumes all the symbols, there is no symbol available. But condition A is not satisfied for the of the slip and deviate, but the B is satisfied, I can find out a pair. If I find out a pair, I do the chain search. Here it is actually very simple. So one of the element I just have to convert it to U because chain will finish here and I will get a low here. So if I have to do the U 4 to 4, so basically what I will say is connect this thing via upper switch and then of course put 3 via lower one and connect to 1 prime. And then of course the last one 2 to 3 also can be done. So 2 to 3 will be Yeah, this is 2 to 3, can go via lower one. Right. And this 3 to 1 corresponds to 3 to 1 corresponds to here, and this is 2 to 3 prime. Okay. So, this is again the same technique which is being used. So, let us do it for an 8 by 8, so that my Paul's matrix size will be larger. I am not looking at the looping algorithm here. So, I can do it so we have got again 8 by 8 and it has again 2, it is also rearrangeably non-blocking, you can actually clearly see. So, this also satisfies that R2 is equal to greater than or equal to 2, M1 or N3. Here also R2 is greater than incoming or outgoing ports in the first or third stage, which is 2. So, here if you want to set up some arbitrary connection, I can again use the same thing. So, let me put up the numbers. So, I will put something arbitrary. Let us set up a connection and let us see what happens. I have to do it again in an arbitrary fashion. Normally if you do it in sequence, you will end up in actually non-blocking system, you will not get a blocking state. So, 1 to 6 if I want to do it, let me do it in arbitrary fashion. Four to 1. Oh, this cannot be done. 4 to 1, you have ended up in the blocking state. So, let us build up the Paul's matrix. This time it will be 4 by 4. But remember, any row can have at most 2 elements, any column can have at most 2 elements. So, 1 to 6 when I did, it was through lower, so 1 to 6 was through lower, then I did 3 to 7 which was lower, and then I did 5 to 2 which was upper, and then I was doing 4 to 1 which corresponds to this row and this column. But look at this row, L is there and U is there, you can't do anything. So, you have to again do the chain search. So, chain will end here, chain will end here. So, I have to just take one of them. So, I can actually make it L and make it U. So, 5 to 3 I can, instead of taking from the top, I will take it from the bottom. And then I can set up 4 to 1. Then I can try 7 4. Two to 3, let me do. I cannot do 2 to 3. Again there is a blocking. So I have done 4, 7 to 4 is here, 7 to 4 has been done through upper, and then I am doing 2 to 3. So 2 to 3 is this column. So this is U, this is L, again nothing can be done, I have to replace something. So I can either make it L and put an U here. So which is 7 to 4 has to go via lower thing. And then I can set up 2 to 3. Okay. Then 6 to 8 prime, let me see if I can do it. Yeah, it was through, and 8 to 5 prime. I could do the connection. So you can see 2 times I have done the rearrangements and I have used the Paul's matrix. Same thing you could have solved using a looping algorithm also.